All right, so welcome back. We are going to go over some more rational stuff. This lesson is called Just Act Rational. So by the end of today, you'll be able to add, subtract, multiply, and divide rational expressions. Okay. Say what, Ms. Johnson? We're going to add, subtract, multiply, and divide rational expressions. So how are these operations performed on rational expressions, like operations performed on rational numbers, aka fractions, right? How are we going to use our understanding of fractions to build our understanding of rational expressions? That's what we're basically doing. So what ideas from fractions are revealed when we change forms? So here's the second part. Okay. I consistently say this: because it works in fraction land, it's going to work in rational land. Okay, because it works in fraction land, then it's going to work in rational land. So for those of you who are like, oh no, I hated fractions or whatever, I'm gonna give you some positive ideas here. Because you're a little bit older and you've seen patterns and you've been in my class, you know how to look at things a lot better than you did as a 5th and 6th grader. Okay, so for those of you who are saying, oh, Ms. Johnson, but you don't understand, I hated fractions. I've had tons of people tell me that. And then we get through the section, they're like, really, that's it, Ms. Johnson? Why didn't they explain this like you did back in 5th and 6th grade? I'm like, they probably did, but you had a different kind of understanding. And plus you're a lot more mature. All right. So in the previous lesson, you saw how connecting rational numbers, fractions, can help us think about rational expressions. In this task, we'll extend that work to consider operations on rational expression. So let's begin with multiplication. In the table, there's missing descriptions and parts of expressions. Use the process for multiplying rational numbers to complete the description of the process and perform the operations to find equivalent rational expressions. So here's our chart that they're talking about. I forgot to grab this. Wait, sorry. So here they want to know what we're doing. So here, can you mentally say, what am I doing? So I'm given this fraction times fraction problem, right? And then what happens, right? And then what happens? So I'm really depending on your skills of observing, your skills of saying different that were developed when you were doing those little puzzles when you were a child, right? What's the same here as here? What is now different? What changed from here to here? So in the chat, if you can tell me what changed from here to here. What changed from here to here? Yeah, for me, they just kind of put the top with the top, yeah, and the bottom with the bottom. That's all they did. They just put the top with the top and the bottom with the bottom. Good. From here to here, from here to here, what did they do? From here to here, what did they do? Yeah, they broke things up by factoring. They broke things up by factoring. So instead of me looking at a 6, I'm now looking at a 3 times 2. Instead of me looking at a 4, I'm looking at 2 times 2. So here, you can write a couple of things, but we'll talk about that in a second. Last but not least, here, what did they do from here to here? What did they do from here to here? Yeah, they just multiplied out. That's it. Okay, everybody okay with this? So far, so good? Yeah, they canceled, someone said they canceled out like terms and then they multiplied. Very good. So I'm going to take these thoughts and apply them here and here, because I said that if it works in fraction land, it'll work in rational expression land, right? So I'm going to take notes on my notebook. Wow, what did I was not ready. I passed out 4.5 for you guys, in case you were wondering. All right, so this is ready, set, go. Scoot it over. All right, so let's start by filling out this chart. I'm going to make you a tad bigger. All right, so here, you guys said that they're going to multiply the numerators and multiply the denominators, right? So I'm just going to put multiply numerators, multiply denominators. Okay. I hope I'm in the right section. I am. I hope I'm in the right section over here. Yeah. Oh, it's just taking a while. Sorry, Ms. Johnson, you need to be patient. All right. So multiply the numerators and the denominators, multiply the numerators. So then what should I write here? What should I write right here for this one? Did they do anything? Did they add, subtract, multiply, or divide here? No, they just literally put them together. Okay. So you want me to put them together? Sure. So make one big fraction. I'm just going to pull the 5 to the front so I don't forget about them. So I got 5x parentheses x minus 3. Everybody okay with that? And the bottom, I'm going to put x squared in the front just because we put single terms or monomials in the front just so that you don't lose them. So any questions on this very first step? Any questions on the very first step? Okay. So what did we do here? What did we say we did here? Where did my 6 go? Yes, you factor. Very good. So here we're going to factor. And then they also took out or divided out common factors. The word common means same. Same on top, same on the bottom. Okay, so that's all we're doing. So I'm going to write this again because there's nothing to factor here. Everything here is already factored. So I'm going to write that same thing again, or I'm going to be lazy and just copy and paste it because that's what I can do because I'm a boss. And then I'm going to look for common factors. Does anybody see, this is already factored. Does anybody see any common factors? Common factors. Yeah, the X. Now, there's a lot of X's here, and it matters on which X you're choosing. If you choose this X right here, if you cross off this X right here, you're wrong. That is the wrong X. That is not okay. Okay. Why, Ms. Johnson? Because that X is attached to that -3. The only way you're getting rid of that X is if that whole thing goes. So you can't do that, Ms. Johnson? No, you can't do that. So don't do it. Okay. So if you chose this X in the monomial with this X and the X squared, then that works. So the way I cancel is I go like this. I say X divided by X would leave me with X on the bottom. Does everybody see that? And the reason why is because X divided by X equals to 1. And 1 times anything is that same anything. Okay, everybody okay with me so far? Any questions so far? What is the confusing part? What is the confusing part? Okay, because I have no answers in the chat. Ms. Johnson, this is the part that's confusing. So this one's a lot less confusing because you didn't have to factor. You get over here and they already factored stuff for you. Leave it factored. But notice later on that when you actually have to factor, that's where the kind of difficulty may enter if you don't remember how to factor. So right now, I'm just going to put a big fraction bar and I'm going to put the tops all on the top but the bottoms all on the bottom. I'm not going to condense anything. I'm not going to make anything look pretty. I'm literally just going to copy and paste into one big fraction. Okay. All right. So big long fraction and I write x plus 1. I put x minus 2. I put x plus 5. On the bottom, I've got x plus 2. X minus 2, x plus 2. Okay, done. So that first step, Ms. Johnson, you're not really doing anything. Correct. Okay. The second step, what am I going to do with the second? Ooh, I missed something. Hold on. That's not what I wanted. Stop it. Let's try this again. That looks good. Yay, I did it. What am I going to do with the second step, guys? What do I have to do? Factor and divide out the common factors. It's factored for me, Miss Johnson. Thank you. I'm not going to really give this to you because maybe one of these, but this, do you see how most of the work is already done for you? All you have to do is divide out the common factors. Who are your common factors? Who are your common factors? X minus 2. Ugh, I love that this person said X minus 2. You want to know what I love? What doesn't make sense? When people say X. No, there is no factor of X here. So little reminder on what a factor is. A factor is like is when you break it down and they are separated by multiplication. Okay, it's separated by multiplication. And if so, do you see why someone wouldn't be correct if they wrote X? Does everybody see why that would be wrong? Do you see why you can't just write X as a factor here? Is everybody convinced? Because if you're not convinced, it's going to happen on the test and it's going to be wrong. So I'm going to take this thing and put it over here really quick. So this is wrong. Okay, this is wrong. Let's put this in pink. Wrong. Do not do this. Do not do this. Because over here, you told me to divide out common factors. A factor is when you break it down, it is a polynomial. When you break it down and they are separated by multiplication. This X on this side is being multiplied. This X on this side is being subtracted. So I'm telling you this because as an experienced teacher, this is where my students go down the wrong path. Miss Johnson, but I saw it. It also said wrong across the top here. Okay, so let's go back. People said, Miss Johnson, so what do we cancel out? Someone said X minus 2. I'm taking that whole X minus 2. I'm canceling that whole thing out. That's gone. Anybody else? Someone says, yes, Miss Johnson, those X plus 2s. Everybody see my X plus 2s? Everybody see the X plus 2s? Yes or no? Can I divide out my X plus 2s? Someone says no. Why not? Why not? Why do you get to cancel out the X minus 2s? Is X minus 2 more special than X plus 2? Why not? Yes, very good, because they're both on the denominator. Okay, so let's take our understanding over here. The reason why we can do it is because X divided by X is 1. X plus 2 and X plus 2 on the bottom, they're not, if I simplify that, that would not be 1. The reason why we can is because this is equal to 1. Can you all imagine? This is what I used to do. I used to draw like these cartoon looking ones. Do you guys all see my cartoon looking one? You see it? It's like a big one. This is just 1. This is X plus 1 times X plus 5, which is also known as X plus 1 times X plus 5. This is X plus 2 times 1 times X plus 2, also known as X plus 2 quantity squared. Everybody see this? Everybody see why this is gone? Yay. Yay, Miss Johnson. Okay. Any questions here? Okay, on a quiz or a test, how many of you got a perfect with all of this stuff here? How many of you guys got perfect? Okay, the cool part is that this wasn't even a quiz or test. So if you didn't get it right, not a big deal. So you're just working on, okay, well, when I practice this on homework tonight, then it's gonna be right at some point, right? All right, next little part. In multiplication, does it matter if the common factors are divided out before or after multiplying? Does it matter if you divide these out? Here, it looks like they did it first and then they multiplied. Could you have done it after multiplying? So for example, in this problem here, would it be legit to go like this? 3 times 5, I'm going to go up here. 3 times 5 is 15. So 3 times 5 over 4 times 6. Could you have done it like this? Like 3 times 5 is 15. 4 times 6 is 24. What would your 5th grade teacher have told you right here? You got to write your answer in. What words did they always use? You got to write your answer in. What would you do here, by the way? Is it okay to leave your answer like this? Yeah, you have to simplify. If you left your answer like this on a quiz or a test, your teacher would have taken points off because you can't leave your answer if it's not simplified. Same thing goes here, right? So if you couldn't do it in fraction land, then you really shouldn't be doing it in rational land. But they ask, can you divide out the common factors after you multiplied? So I just multiplied, and then the common factor obviously is going to be 3. So I'm going to divide out my 3 here. What's 15 divided by 3? Just kidding, I know. What's 24 divided? Just kidding, I know. So it doesn't matter. Look at what the work we did. First, here, we factored out, then we multiplied. Here, we multiplied, then we factored. Our answers are, you guys all know that this is going to be an 8. It's going to just show up one day. Does it matter? Yeah. You, by observation, understand that it doesn't matter. But here's the more important part. Why not? Why doesn't it matter? Why doesn't it matter? I'll give you a hint. Has to do with this. So PEMDAS tells me the order in which I have to do things first, second things second. Sometimes there's things that I could do at the same exact time, right? So they say that you have to multiply and divide from left to right. Literally, you are multiplying. Here, you're dividing out first. Here, you are dividing out last. This is like one of those things. Should you brush your teeth or make your bed first, right? This is not socks and shoes. You have to do socks, then shoes, right? So factoring out first is my preference because you're making your numbers smaller and then bigger rather than here, bigger than smaller. So some people are like, but Ms. Johnson, it really doesn't matter because this is 15 and 24. Yeah, but over here, it would matter because now you're factoring out a bigger polynomial. Okay, so this is my preference. You do not have to do what I say by any means, but I'm just telling you, as a seasoned mathematician, this is kind of like the way I've learned that I like doing things. Okay. So the next thing you and your group are going to go do, you're going to practice division. We already talked about dividing. You know how to divide. We talked about it's just really multiplying by the reciprocal. Okay. So you'll notice that these steps look the same. Multiply and divide out any common factors. Same thing goes. So I'm going to pause the video here. You guys are going to go in your group. Okay, so if you noticed the dividing by a fraction was very, very similar to multiplying by a fraction. So we're not going to spend a lot of time on it. I really want to get to the other part. So obviously here, in order to get this as a product, you needed to divide by a fraction here. So this one should say 3/4 divided by 5/6. I did not write 5/6 wrong. That is correct because you have to multiply by that reciprocal, right? So here, this would be multiply by reciprocal. And make sure you're reciprocaling the right fraction, right? Not the first, but the second. So then you just, then this part from here on down is exactly the same. You're going to divide out any common factors, and then you're going to multiply to write an equivalent expression, okay? So here, you're going to do the same thing. You're going to write out the first fraction. You're going to multiply by the reciprocal, so the bottom goes to the top and the top goes to the bottom. If I had time to explain why you actually divide by the fraction, I would. So maybe I'll explain that another day. Then you multiply and divide out any common factors, right? So here you should be looking, right? You should be linking all these guys together. So x minus 2 I should have put X in the front. Who cares? I'm just gonna leave them in the middle. And then I got X plus 2 on the bottom and X plus 5. So you're looking for any common factors. So does anybody see any common factors here? What common factors do you see? Yeah, so very good. X plus 2 goes, and then that's all you're left with. X minus 2 on the top, boom, and X plus 5 on the bottom. So no, Ms. Johnson prefers this way. I'm going to leave this one for you to do and make sure that your answer is correct. Here's your answer. It is correct. Ms. Johnson, where'd the fraction go? The fraction technically is still there. You can put it divided by 1, right? What you're saying is my denominator, they were all factored out, right? They were all common factored out. So how could you use to check your answer performing an operation on a pair of rational expressions? So if you know me, what's one way to check my answer? What am I going to bring up right now? I'll give you a hint. Yeah, I'm going to bring up Desmos. And the way we're doing this is I'm going to put this whole expression in here. And then I'm going to put this whole expression in the next line. And what should happen? What should happen? Very good. The two functions should be right on top of each other, right? If they're not on top of each other, you did something wrong. You messed something up, okay? I wanted to move on. I know we only have 2 minutes, but I wanted to move on to this just to give you an idea of what I'm looking for. Here, you could already see this. You can review this on your own. Notice when you don't have a common denominator, you multiply so you get a common denominator, right? In this case, our common denominator is going to be multiplying our two denominators. So what would you have to multiply 3 by to get 21? Well, that's 7/7. And what would you have to multiply 7 by? So then you're multiplying by 3/3. Notice these two are just the ones, right? That I keep drawing for you guys over and over again. These are just ones. And this is legit in math. You can't just pick a number and multiply it by it, right? That'd be really cool, right? You have a $20 bill and you're like, boom, I multiplied it by 20, Miss Johnson. Now I have $2,000. That's not the way it works, okay? In reality, we're just multiplying by the number 1. That's why it's legit to do. So I'm going to talk to you so that you guys can see how this works. Nothing new. Notice we didn't learn anything with multiplying. We didn't learn anything new with dividing, and we're definitely gonna learn anything new with adding or subtracting. So here goes. I'm like, okay, I need you guys to add this. And you're like, wait a second. Oh, so this is kind of like this. I need a common denominator. So your brain goes, I need a common denominator. So well, the common denominators for rationals is a lot easier to think about than actual rational numbers, because you just take the other and put it on the other, and you take the other and you put it on the other, right? That's all you're doing. And then you multiply top and bottom. So I'm going to do this next part here. So I'm going to draw a big O line on the bottom, and I'm going to go X plus 7 times X minus 4. And it's one denominator, okay? This is how me and them differ. I'm already going to jump to this point right here. So then I'm going to multiply out. So I'm going to multiply 3 times X minus 4. So that's 3X minus 12. I'm using the distributive property. This makes sense, right? And then I'm going to do the same thing here. So that's going to be plus 4X minus 28. Okay, and then I'm going to keep my denominator, X plus 7, X minus 4. And then now look, it's going to be 3X plus 4X. That's 7X, right? Oh, why did I put minus 28? Sorry, guys, that's plus 28. So then negative 12 plus 28 is 16. The last little step is I'm going to make sure that I can't factor 7X plus 16. And I can't because they don't have any common factors. So there's my answer. Your last step for every single problem is going to be, can I factor anything else out? Can I factor anything else out? Here, you can't factor anything else out. So that's why your answer is your answer. Here, you can't factor out anything else. So there's the end of our lesson.